Welcome back, children. Today we are discussing Icse Maths Class 6 Chapter 4 Sets. Okay, then tell me what's a set. Do you know? You can see so many types of sets around you. Any one example can you say? Yes. Sets of flowers, sets of animals, sets of books. So many types you can see. Okay, so we can write sets is a collection of objects. But in maths, set is a collection of well-defined objects. In maths, set is a collection of well-defined object. Okay, for example, I will tell an example, then it will be more clear. Colors of a rainbow. Colors of a rainbow. Colors of a rainbow. Tell me how many colors are there in a rainbow? How many colors you can see? Yes, 7 colors you can see. That is Vibgeo. That is violet, indigo, blue, green, yellow, orange and red. So you can see 7 colors. Okay. It is well defined. We can see 7 colors in a rainbow and it is well defined. So we can say this one colors of rainbow is a set. It is a set. Example for set. Okay, then another one, interesting books in the library. Second one, interesting books in the library. Now tell me, is it a well-defined set? Is it a well-defined object? No, because you like comics and your friend like adventure stories. So it is entirely different, person to person, child to child. Okay, so it is not well defined. So we can say it is not a set. Clear? Vibgeo is a set because it is well defined, but interesting books in the library is not a set because it is not well defined. It differs from person to person. Okay, now let us check the exercise 4a. Our question, planets in our solar system. It is already written in a book, the name of the planets, number of planets and all. So it is well defined. So it's a set. Second one, interesting book that I already told. Then colors of a rainbow. Yes, I already told. Then next one, fourth one, all difficult problems in your math book. All difficult problems in your math book. Is it well defined? Is it changes from one person to another person or one student to another student? Yes, because some of them like algebra, some of them like calculus. That means some of them like pure mathematics, that is numbers only. Okay, some of them like with variables, that is x, y, z. Okay, so it is entirely different, so that is not a set. Then next one, top 5 wicket takers in Test cricket. Is it a set? Yes, it is already written. Okay, it is already written. So it is a set. Next one, intelligent boys of your class. Is it a set? No, because some children is intelligent in maths, but another one is intelligent in physics or chemistry. So it is different. So it's not a set. It is not well defined. Then next one, President of India. Yes, all can say the same names of presidents. Okay, name of the president. So it is well defined. Then next one, good football players. Good football players. If you like Messi, it is not necessary that your friend like Messi. Sometimes he like whom? Neymar. So it is different. So it's not a set. Next one, counting numbers between 30 and 40. All can say the same answer, 30 and 40. How many numbers are there? 31, 32, 33 up to 39. So it is well defined. Then next one, all good schools of India. All good schools of India. Okay, this is means if your parent like St. Mary's or another parent like Silveris, it is different. It is different. That means it is not a well-defined set. Next one, all vowels. All vowels. Then tell me, if I ask which are the vowels in our alphabet, all children will say the same answer, that is A, E, I, O, U. So it is well defined. Then next one, all yellow fruits. It is also well defined. If you say mango, yes. If you say another one, or yellow orange, you can say. You can say, so yes. Then yellow apple, yes. So all are yellow. It is well defined. The color is well defined. So it's a set. Clear? Now take your book and write. Set is a collection of well-defined objects and example for set and example for not a set. Okay. Next one, members of a set. Membership of a set. Okay, if one take membership in science club, then the science teacher will say he is a member of our club. Okay, if one take a membership in math club, they will say he is a member of our math group. Okay, if same way, if, we know that the colors rainbow is Vibgeo, then you can say I is a member, or it is another name is there, that is member or element of the set colors of rainbows, colors of a rainbow. So I is a member of or element of the colors, element of the set colors of a rainbow. Okay, same way, V is a member, then R is a member or element, and it is denoted as I is a member. This symbol denoted as member of or element of. I is a member of colors of a rainbow. So I is a member. If when I say S is an element of colors of a rainbow, is it correct? No, it's not correct. S is not an element. So at that time, this symbol denote not an element of. That is, first you write element of, then not an element of. So not an element of colors of a rainbow. Clear? Okay. So next example. I'll write another example. Example, 7 is an element of the set of odd numbers. The set of odd numbers. It is correct. When I write 8, is it correct? No, it is not a odd number. So it is not an element. Clear? Okay, so many examples are given in your textbook itself. Then one more, the 9 is not 9 is an element of set of square numbers. Yes, 9 is an element of set of square numbers. Is it correct? Is it correct? Yes, because we know that 1 square is 1, 2 square is 4, 3 square is 9, 4 square is equal to 16. So 9 is an element of set of square number. Clear? Okay, very good. Now take exercise 4b. Our first question, B is an element of. First question, B is not an element of A, E, I, O, U. Okay, we are writing sets inside the curly bracket or braces. Okay, curly bracket. So B is not an element of the set of vowels, that is A, E, I, O, U. Is it correct? Yes, B is not an element. Here only elements are A, E, I, O, U. So it's not an element. Same way you can do the next questions yourself. Then after that, representation of a set. How to represent a set? How to represent a set? Okay, we can represent sets in three different ways. We can represent sets in three different ways. Okay, so many ways are there, sub ways are there, but we are only taking three main ways to represent a set. That is, first one is okay, so our first representation is the description method. We are representing a set using the description method. The description method. Then our next type is the roster method. Description method, the roster method. And our third type is rule method or set builder form. Rule method or set builder form. Okay, so these are the three different ways to represent a set. Then in description method, the description method, a set can be represented by describing. We are describing. We are represent a set using sentences. We are represent a set using sentences. So that is, we are describing a set. We are describing a set. Okay, we are giving a description of that set. That is description method. I will tell an example. The set of letters in the English alphabet. We can write the set of letters in the English alphabet. Okay, so we are describing it as the letters are in the set of English alphabet. Then how can we write the same in roster method? What is roster form? Roster means we are roasting. We are making it in the roster form. Okay. Otherwise, I will say one example. Roster. Here the spelling of roster is R-O-S-T-E-R. But what means roast? Roast means we are frying. So at the same way, we are frying. First you have to write the curly bracket and write all the English alphabet by inserting commas between each English alphabet. F, G, H, I, J, K, L, M, N, O, P, etc. up to Z. Okay. That is, we are writing all the members of set by putting commas between two members. That is the roster method. We are taking each one separately, okay, and we are roster method. The next method is rule method. That means some rules. We have to given some rules. Okay, in that method, same way we have to put a curly bracket. After that, write X such that. You can either use double dot or you can write a slash, put a slash to represent X such that. Both ways you can write. Both way you can use. Okay, so here I am writing X such that. What is the condition there? What is the rule there? X is an element of which set? X is an element of English alphabet. X is an element of English alphabets. That is, you are writing a rule there. X is an element of English alphabet. The value of X is such that X is an element of English alphabet. So this is the three methods used here. So I will tell another example for the same. The set of last 3 months of the year. So which method is that? The set of, my second example, the set of last 3 months of the year. Okay, so this method is known as the description method. That is, we are describing. So this method is called description method. Okay, then our next method is the roster method. Then tell me, how can we write the set of last 3 months of the year? October, November, December. Which are they? October, November, December. These are the last 3 months of the year. So we'll make a set that is October. Then our next member is November. And our next member is December. So this is the roster form. Then how can we write it in the rule method? That is, X such that X is an element of last 3 months of the year. Okay, X is an element of last 3 months of the year. So this is the rule method or set builder form. Is it clear now? Thank you, children. Next one. Do the next exercise yourself. Fourth C, so many questions are there. So do it yourself. The next one, types of sets. Types of sets. First one is finite set. The next one is infinite set. The next one is singleton set. Then another one is empty set. So this year we are studying 4 types of sets. One is finite set, that is we can count the elements of that set. Then second one is infinite set, it is infinite, we can't count it. We can't make a total count of that set. Then singleton set. So what is single parent? Single parent means only one element, one parent is there, single parent. So if mother is there or father is there, either mother or father, that means single. You are single means you are alone, single, one. Single child means one child. Okay. So same way, first one, finite set. For example, I will tell an example. A is equal to set of 1, 3, 5, 7. Okay. Here you can say only how many members are there? 1, 2, 3, 4 members are there. That is, you know the number of members in that set. So it is countable. So it is a finite set. It is countable. So it is a finite set. Then tell me an example for infinite set. The set of Okay, we denote the set of natural numbers as n. So we can write set of natural numbers as 1, 2, 3, etc. etc. It is, and so on. That means it is not countable. We can't count count the number of elements in that set. If we say 10 lakh and above, you can say another number, 11 lakh, after that 100 lakh, after that 1000 lakh. So it is not countable. So these types of sets are called infinite sets. Okay, next one, singleton set. Okay, singleton, single, I told single, only one element. Okay, for example, a set containing only one element is called a singleton set. For example, 7 is a singleton set containing only one element, namely 7. Okay. If the set contain only one element, then it is called a singleton set. If the set contain only one element, then it is called a singleton set. For example, a number which is neither prime nor composite. A number which is neither prime nor composite. Which is that number? Which is that number? And a set of number which is neither prime nor composite. Yes, only one number is there. That is number 1. So this is called singleton set. Then empty set. That means if there is nothing, we will tell it as empty. Okay, that concept is empty. So empty means nothing is there. Empty means nothing is there. For example, the set of trees 1 kilometer high. The set of trees 1 kilometer high. Can you say any tree like that, set of tree like that? No, there is no 1 kilometer tree. Okay, which height is 1 kilometer? That means not the width. Width is also, it is impossible. Width and height both are impossible. 1 kilometer, it is not possible. So that time we can say that type of sets are empty, and it is representing, empty is representing using the symbol phi. Or you can simply write two curly bracket without member. So that set is called a empty set. Clear? Okay, then empty set I told. Then anything left? And one more example for empty set. Say if I write 1, 2, 3, etc. and if I say these are the set of natural numbers, can you see 0 in this natural number set? No, that is empty. There is no 0 in that natural number set. Okay. So next one, cardinality of a set. Next example, first you write here finite set, a set that contain countable number of different members. A set that contains countable number of different members. Is called a finite set. Okay, then next one, next example, infinite set, a set that contains unlimited number of different members. A set that contains unlimited number of different members. Okay, is called a infinite set. Then next one, singleton set, a set containing only one element. A set containing only one element is called a singleton set. Okay, then next one is a set that contains no members. A set that contains no members is called an empty set. So take your book and write it. Okay. Next cardinality of a set. Next one. Cardinality of a set. Okay, what is cardinality? Cardinality of a set. Cardinality means the number of elements of a given set is called the cardinality of a set. For cardinal number means cardinal number. Next one, cardinal number. Okay, the number of distinct elements in a finite set is called the cardinal number of the set and denoted by the symbol n of a. N of a, where a is the given set. For example, I will explain how to find the cardinal number. 0, 1. Okay, if the given set is set 0, 1, then what's your cardinal number? Find out the number of set, this one, number of set, that is 1, 2. So your cardinal number is 2. If I told you to write the members of the word capital, the members of the word capital, how you will write? You will put a curly bracket first, then C A P I T, one more A is there. So don't write that A, don't repeat any numbers again. You can write a member only once. Okay, only once at a time you can write that number. So don't write A again. Next you write L. Okay, now count the numbers 1, 2, 3, 4, 5, 6. So your cardinal number is 6. Now write it, the cardinal number, the number of distinct elements in a finite set is called the cardinal number of the set and denoted by n of a. Okay, next one, cardinality of a set is a measure of the number of elements of the set. Then next one more, two more things we have to study, that is equal sets and equivalent sets. Equal sets and equivalent sets. So equal sets, two sets are said to be equal if they contain exactly the same or identical elements. In case, means equal sets means if it contains the same type of elements, not same number, same type of elements. For example, if A is equal to PQR, the set PQR, and B is equal to set QRP. QRP. Okay, QRP. Another example you can write, if the sets are the members of the sets are in the word pot and top. Pot and top, both are same. The members are same. The words, the word pot and top, both are different, but the members are same. So that is called equal sets. When the members are same, then it is called equal sets. The word pot, the members are POT, and in the word top, the members are TOP. Both the members are same in that set. So write it. Two sets are said to be equal. Write it. Two sets are said to be equal if they contain exactly the same or identical. Identical means same type. Okay, same or identical elements. Okay, examples are there. So, you know what are equal sets. Next one, equivalent sets. Equivalent. Equal and equivalent both are different. Equivalent sets. Here the number of members are same, but members are different. Okay, for example, if A is equal to the set XYZ and B is equal to the set ABC. So here you can see number of A is equal to cardinal number is 3. Here cardinal number is 3. So the number of elements in these sets are equal but they are equivalent but they are not equal. That is the difference. So the two sets are said to be equivalent sets if they contain the same number of elements. Write it. Two sets are said to be equivalent sets if they contain the same number of elements. Now nothing is left there. This chapter is over. Very easy chapter. So study it well. All the best, children. Thank you.